So today, we have some learning targets here. We're going to find all of the real and complex zeros of the polynomial by factoring using the graphing calculator and or using the quadratic formula. So if you remember complex numbers, we're going to be having some i's in some of our answers here. So our goal here is to factor at least to a quadratic, and then we can use our quadratic formula. So when we're doing this, we want to try to factor if at all possible. So you've got your regular factoring, and then don't forget that you could factor by grouping. So if you've got an even number of terms there, think about grouping them in twos. We can also, don't also forget with factoring there, you have GCF as well. So look to do GCF as well. If you cannot factor, use a graphing calculator to find the zeros. If not down to a quadratic or less, then we have to use our zeros and synthetic division to check for multiplicity. So let's look at this first one. Looking at that one, it's an odd number of terms there. So we can't factor by grouping. I don't see a GCF in there. I don't see anywhere to factor that. So I'm going to go ahead and plug that into my graphing calculator there. So 3x to the fourth minus 2x to the third minus x squared minus 12x minus 4. And then once we have that, we can hit graph. And there we have it. Notice those are, looks like there's two of them, and it looks like that's going straight through those, although we can't entirely tell. So let's see if we can get those two zeros. So I'm going to check my table there and see if I can get, I think that one over there on the right hand side is a 2. So if I look here on the table, yes, 2, 0. I'm not sure the other one over there, whoops. The one over there on the left hand side over here, the x-intercept. The one on the left-hand side over there, that one there is somewhere between 0 and -1. We can find that one. Our calculator will actually find that for us. We can do second calc and go down to 0 and hit enter. And then we want to move our cursor to the left side, because down at the bottom it says left bound, so that's the left side of the x-intercept of that red dot on there on the left. And I'm going to hit enter. Then it says right bound, so I want to move it to the right side of the point that I want. So now it's on the right side of it. I'm going to hit enter. It says guess, and then it's going to put it right there at that spot. And then it's -0.3 repeating, which is -1/3. So our two zeros there are x equals 2 and x equals -1/3. We found those using the graphing calculator. So now we're going to have to go ahead and see about the other two there. It says x to the fourth, so we need to have 4 zeros. So let's go ahead and let's use synthetic division and see if we can get this down to a quadratic. So using the 0 there, I'm going to put it in a box here too. And the numbers I'm writing down there are the coefficients, those numbers that are right in front of each of the x terms there. So x to the fourth there has a 3 there, and I just go across and write them down. I'm going to bring down my first number, which is a 3, multiply by what's in the box, add, and we get 4, multiply by what's in the box, add, and we get 7, multiply by what's in the box, add, we get 2, multiply by what's in the box, add, we get 0. So then we have to use synthetic division again. But before we do that, remember we started off there up there at the top with 3x to the fourth. Well, now this is going to drop down by a power here, so this becomes 3x to the third plus 4x squared plus 7x plus 2. So now our other 0 here is -1/3. Let's use our coefficients of this x to the third polynomial here. Bring down our first term, multiply by what's in the box, add, multiply by what's in the box, add, multiply by what's in the box, add, And so now we're down to, we just went from x to the third, drop it down by a power. So now we're down to x to the second plus 3x plus 6. All right, so now we have a quadratic. That was our goal, to get it down to at least a quadratic here. So we got it down to a quadratic, so now we can use either factoring or use the quadratic formula. So let's go ahead and just use the quadratic formula. So quadratic formula says x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So plug your values in there. So b there is 3, so opposite of 3 is -3. Plus or minus the square root there of 3 squared minus 4 times 3 times 6. All over 2 times a. So now I'm going to simplify this. I get -3 plus or minus 9 minus 72 in there. 9 minus 72 there is going to give me a -63. Break down -63. So remember, the square root of -1 is equal to I. And the square root of 9 there is 3, so that's a square root of 9 there is 3, so you get a 3i. Square root of 3, or sorry, square root of 7. All over 6. Now remember how we break these down. If the numbers on the outside are all divisible by the same number in all 3 spots, you can go ahead and reduce it down. So can you reduce that down? Yes, because 3 goes in each one of those. 3 goes in a -3 there, -1 times. 3 goes in a 6 there once, and 3 goes in a 6 there twice. So 3 went in -3 there, -1 times 3 went into 3 there once, and 3 went into 6 there twice. So then if we're going to list out our zeros here, our zeros there are x equals 2 with a multiplicity of 1, x equals a -1/3 with a multiplicity of 1, and x equals, if I pull this apart over here, I could write it like this too, -1/2 plus or minus I squared of 7 over 2. So either one of those works. So there's a first one there has 1, this has 1, this is 1, and then this is 2 because it's -1/2 plus I squared of 7 over 2 and -1/2 minus I squared of 7 over 2. But each of those have some multiplicity there of 1, but there's 2 answers in that, and then that third one there. So there we have them. All right, so example 2 here. This one here, if you notice, it has an even number of terms, so we might be able to go ahead and factor this by grouping. So looking at those first 2 terms, what's the GCF? The GCF there is x to the 4th. If I take x to the 4th out of that x to the 5th term there, what's left? An x. If I take an x to the 4th there out of that second term there, what's left? A -2. All right, what about the second set over there? What's the GCF there? It would be a 2x to the second. So then what's left? X minus 2. And then our other one there, we gotta pull out, it doesn't have a GCF, so we have to pull out a 1. So then what's left? X minus 2. Make sure you put that 1 there. That's what it has in common. So now if you look at all 3 of these terms here, what do they all 3 have in common? All 3 of those terms they have in common an x minus 2. And then what's left in front? All right, so let's see if we can still factor down that x to the 4th plus 2x squared plus 1. So what times what gives me x to the 4th? Oh yeah, x to the 2nd. What times what gives me 1 and adds to give me a 2? A 1 and a 1. So does that work? Check the inners and outers. A 1x squared plus a 1x squared does indeed give me a 2x squared, so it does factor. All right, so let's come down here and let's figure out what our zeros there are. So we can set each one of these equal to 0 here, so I can say x minus 2 equals 0, x squared plus 1 equals 0. So this one here ends up being x equals 2. I have to go ahead now and take the square root of both sides. I'm not going to forget my plus or minus there on the outside. And the square root of -1, what's the value of that? Oh yeah, I. And then don't forget, that's the same as over here. So let's list out our zeros. We have x equals 2, and that has a multiplicity of 1. We had x equals I, because it occurred over here, it's a plus I right here, and a plus I over there, so it has a multiplicity of 2. And then we have x equals a negative I, and that has a multiplicity of 2. So if you add them all together there, you get 5. So if you go back up there at the top, it was an x to the 5th, so we have our 5 zeros. All right, so now we have this other one here. Again, find the zeros of the polynomial. So looking at that one, I've got 5 terms in there, so I can't factor that one by grouping. Not seeing any way to factor that, so I'm going to go ahead and use my graphing calc. So let's do that. Plug it into your graphing calculator there. So let me clear that out of there. So we got x to the 4th plus 2x to the 3rd minus 2x squared minus 6x minus 3. Hit graph. It's looking like maybe a -1. Let's look there. Oh, yeah, better up here. So a -1 and maybe something's over here. I'm not sure, sir, if that one there on the right side over here is a 2 or if it's a little shy of 2. So let's go ahead and let's look at our table there. And -1 definitely is 0, but at 2 there, not a 0. So that one is not going to work. So we can say x there equals -1. Oops, I want to go back to the graph. So I'm not sure about the multiplicity at that spot there. I'm going to have to check it as I go here and see what's going on there. Seems like, well, actually, let me get rid of the dot there. We can see it better. It's hard to kind of see with that dot on top of it, but hopefully you can see that it's doing this at that spot. It is turning at that spot. It's kind of hard to see that it's turning there a little bit. But hopefully you can see that it starts down and then comes back down. So it is turning there. So we can tell it has a multiplicity there of 2. If you're not sure, because our only choice here is to do synthetic division, you might want to just try it twice. So I'm going to put -1 here in the box here. Coefficients here. Bring down the first term, multiply by what's in the box, add, multiply what's in the box, add, multiply what's in the box, add, multiply what's in the box, add. So then I'm going to try -1 again, because we're thinking that has a multiplicity there of 2. So remember, we drop down by a power. X to the 4th becomes x to the 3rd. So my coefficients, 1, 1, -3, -3. Bring down my first term, multiply by what's in the box. Add, multiply by what's in the box. Add, multiply by what's in the box. Add. So now we drop down by a power. Again, it was x to the 3rd, now it's x squared. So I'm down to a quadratic here. Whoops, forgot my x. I don't really need to write down that 0x there. I just put it in there so that we can see what's supposed to be there, if it needed to be there, if that coefficient was something other than 0. So now our quadratic here simply is x squared minus 3. We're going to set that equal to 0 and solve for x. So the easiest way here is just to go ahead and add 3 to both sides. Now take the square root of both sides. So we get x equals plus or minus the square root of 3. So let's list our zeros out. We have x equals -1. Remember that has a multiplicity there of 2. We have x equals the square root of 3. And x equals negative square root of 3. So there's our 4 solutions. And remember, our degree up there was 4, so the highest power of x up there at the top there was x to the 4th. So we need to have 4 zeros. So -1 there, multiplicity of 2, so that counts as 2, and then square root of 3, and then negative square root of 3. All right, so then example 4 here. Notice we have an even number of terms up there, so let's see if we can factor this one by grouping. So I'm going to pull the GCF out of the first 2 terms there, which is an x squared. Doing so, I'm left with a 3x minus 1. The second set over there, I'm going to have to pull out the negative because the leading term there is negative for that last set there. So I'm going to have to pull out a negative something, and it's a -12. And then I'm left with 3x minus 1. So then what do those 2 terms have in common? They have a 3x minus 1 in common. What's left over in the fronts? X squared minus 12. So now take each one of those terms and set it equal to 0 and solve for x. So this first one here, I'm going to add 1, divide by 3. The second one over there, I'm going to go ahead and add 12. Take the square root of both sides. Don't forget the plus or minus. I'm going to get the square root of 12 here, but I'm going to break that down. What goes into 12? 4 and 3. Square root of 4 there is 2. So I get plus or minus 2 square root of 3. So let's list our zeros out. So there they are. This time we didn't get any complex zeros. So if you come back up here, we didn't get any, I should say we didn't get any I solutions there. So if you look here, we got 3 solutions there, and up at the top there, the highest power of x, and there's x to the third, and we've got our 3 zeros. All right, last example here. So if you want to try this one out and stop the video right now, go ahead and do that. All right, so let's go ahead and I'm going to look at this one. It's got an even number of terms here, so I'm going to see if I can factor this by grouping. GCF in the first two there is x to the fourth. GCF in the second set there is 3x squared. GCF in that last set there is a 2. So now look for what all 3 of them have in common. They all have in common an x minus 4. So what's in front of the x minus 4 is going to write all those down. So now we can continue factoring that x to the fourth plus 3x squared plus 2 if we can. Let's see if we can. What times what gives us x to the fourth? It'd be x squared and x squared. What multiplies to give us 2 and adds to give us 3? That'd be a 2 and a 1. So if you check your inners and outers, does that add to be 3x squared? Yes, it does. So we've got them factored. So now let's take each one of the factors there and set it equal to 0 and solve for x. So my first one there, I can add 4. Second one there, subtract 2, and the third one there, subtract 1. So now I have to take the square root of those second 2 there. So doing so there, I'm going to get x equals, how we do this is that this is like the square root of -1 times the square root of 2 there, so it's going to end up being square root of -1, there's I. And square root of 2, you can't break that down. Over here, the square root of -1, there is just I. So now let's just list our zeros. X equals 4 plus or minus I square root of 2 and plus or minus I. So if you look at that, that's 1, 2, 3, 4, 5, and you have an x to the fifth. So that's what we wanted to get. So our learning target, I can find all the real and complex zeros of the polynomial by factoring using the graphing calculator and or using the quadratic formula.